Okay, this is the third part of our video about trigonometric substitution. This time we're going to discuss the integral of the form square root of x squared minus 4, okay, or your integrand with this particular form. Again, if you refer to the table of trigonometric substitution, you have this form square root of x squared minus a squared, right? Okay, and whenever you have that form, you're going to use the substitution x equals a secant theta, and your identity, of course, na secant squared theta minus 1 equals tangent squared theta. Okay, so let's solve this. As I've said from our previous video, even without the trigonometric substitution table, you can also actually derive the expression for your x by using this diagram, where this is your theta. So you have this particular form, no? Obviously your x here is the hypotenuse because of the Pythagorean theorem, right? Now you have to decide where to put 2. Either you put it here or here. Now you have to be careful, because if, for example, 2 is misplaced, then instead of using the substitution x equals a secant theta, you'll be using x equals a cosecant theta, which is still okay, because that will still work. But to be consistent with what we have in the table of trigonometric substitution, let's choose to put 2 here. Okay, so using Pythagorean theorem, that would be, this side would be square root of x squared minus 4, right? Okay, so your x is what? What is your x? You have adjacent to, and x here is hypotenuse. If you recall, we have the acronym for to recall the expression for sine, cosine, tangent, and so on. So TOA. And what's involved here is hypotenuse and adjacent. So question, is it cosine? Yeah, we can use cosine, but I think it's easier if we use secant instead, because cosine is just the reciprocal of secant. That means that your secant actually is hypotenuse over adjacent. It will be siya actually, no? In other words, SOHCAHTOA, cow, because tangent is the reciprocal of cotangent, cow, siya, and then cosecant, okay, the reciprocal of your sine. So we're going to use this one. Okay, that means that secant theta is hypotenuse over adjacent. That means that your hypotenuse is actually adjacent, which is 2 times secant theta. Or you could just have referred to the table. Okay, so with that as our x, what is the dx? Dx is 2. The derivative for secant theta is secant theta tangent theta. Okay. And we want an expression for square root of x squared minus 4. So we have square root of x squared minus 4, which is equal to x being your 2 secant theta. So square all that is 4 secant squared theta, then minus 4. Again, 4 is common. Square root of that is 2, so you have 2 square root of secant squared theta minus 1. Okay, but what is secant squared theta minus 1? From the identity I've shown you a while ago. Okay, secant squared theta minus 1 is tangent squared theta. So replacing this with tangent squared theta, this will become 2 tangent theta, because the square root of tangent squared theta is tangent theta. Okay, then let's do substitution. The integral of square root of x squared minus 4, which is 2 tangent theta over x, which is 2 secant theta, times dx, which is 2 secant theta tangent theta. And then simplifying, we have integral of so we cancel this, okay, and then we have 2 here, then you have tangent squared theta d theta, and this is 2. We don't have integral for tangent squared theta, right? But we can use an identity for this, which is secant squared theta minus 1 d theta, and then the integral of secant squared theta is tangent theta, and then the integral of negative 1 is theta, then plus c. Again, we have to put back or express this answer in terms of x. This time we're going to find for an expression for tangent theta. Now remember this, your square root of x squared minus 4 is equal to 2 tangent squared theta, which means that you have 2 tangent theta. Okay, 2 tangent theta is square root of x squared minus 4, then minus 2 theta. But what is theta? Theta here can be expressed in terms of either you use secant squared theta, or you can use cosine, maybe cosine inverse, or maybe tangent inverse. It's up to you which to use. Just to remind you, whenever you have, for example, tangent theta equals something, say a, this means that your theta is tangent inverse of a, right? Okay, so you can actually express your theta, either use secant or this one. You can use secant and then convert that to cosine, kasi x equals 2 secant theta can be written as x equals 2 over cosine theta, right? Which means that cosine theta is 2 over x. So theta is, from here, theta is cosine inverse of 2 over x. Or we can just use tangent. But I think using cosine is simpler. So you have square root of x squared minus 4 minus 2 cosine inverse of 2 over x plus c. Okay, so that's it.